Hey everybody, I'm going to talk about parts of chapter 9 here in this first part. This chapter covers homeostasis, motivation, and reward. So we're going to take a look at things like thirst and hunger and motivation, all right, and reward. So let's begin, all right? So here are the learning objectives, and this PowerPoint that I'm using is on the course page. And so as I go quickly through some of this, and when I skip certain slides, you can download it yourself and look at it at your leisure, all right? So we have a bunch of regulatory systems, and they generally work, but we have complications, in modern times with obesity, and it's it's kind of a sad reality about how evolution has worked to create a drive to eat, and especially foods that are high in things that will lead to obesity. Because in evolutionary times, food was much more scarce and hard to come by than it certainly is today, at least in affluent cultures like our own. So we just kind of have a runaway problem with it. And, and as we see here, obesity rates have climbed in our country and in many Western cultures. And the good news is that it hasn't risen as high as it was projected to. These figures I have here go to about 10, 11 years ago, and at the time, obesity levels in the U.S. were about a third, about 34% of Americans were considered obese, and projections were that we by 2020 we might reach levels as high as almost double that, maybe even as high as 70-some%. I believe it's higher than 34 these days, but it certainly is not it has not doubled. That's the good news. At the same time, about 1 to 3% of Americans are diagnosed with anorexia or bulimia, and so we have conflicting systems here. All right, so let's dive in and take a look at this in general. So homeostasis was a term coined way back in the 30s by Walter Cannon, and it refers to an organism's ability to adjust to its processes in order to maintain a level of equilibrium, to reach to have and defend set points for these things that we're covering: temperature, fluid levels, and body weight. This chapter also covers motivation and reward, and we'll cover, if I get to that, we'll cover that in probably another segment. But the chapter does include motivation and reward. And so motivation is a process that activates and directs our behavior. All right, so these deviations from these physiological set points that our homeostasis process is trying to defend lead to an unpleasant state. It generates this unpleasant state, which is going to motivate us. It's going to drive us to try to reach that equilibrium. All right, so. And the resulting behaviors that it motivates are going to be specific to that drive state. So, for example, we don't seek out, water. We don't get thirsty when we're hungry. We don't put on a sweater when we're thirsty. Okay. So, a general phenomenon with these homeostasis processes are feedback systems. So these are tantamount to a thermostat, that we plug in a set point, and if we have an air conditioning and heating system, that's driven by one thermostat. We can plug that in, and if the temperature rises too high, the air conditioning will kick in and bring the temperature back down to that set point, at which point it will cut off. And if it gets too low, it might trigger the heating system to turn on and raise the temperature until it reaches that set point at which it would shut off. All right, so if everything's working normally, that's how these sort of these systems work. So you have a complicated system of a thermostat system to regulate your temperature, and similarly, you have systems that are regulating your fluid levels and your nutrition and food levels. All right, so this segment we're going to look at body temperature. All right. We have a rather precisely defined set point, and we have physiological mechanisms for detecting deviations away from that set point, just like the thermostat did for your home. And so there are internal and behavioral elements designed to regain that set point. Okay, so we'll break that down and we'll look at each of those. So the internal and behavioral elements. So all animals, including us, have to maintain this internal temperature for our normal activity, our normal cellular and physiological activity. Wild deviations from it, of course, are dangerous and lethal. All right, so there's two primary adaptations that have developed to respond to these challenges and to maintain temperature. So some organisms are considered ectotherms, and these include things like amphibians, reptiles, fish, so-called cold-blooded creatures, which is a misnomer. And they're going to rely more on external factors to maintain their body temperature. So they're going to seek and these are behavioral strategies. So they're going to seek sunlight and to raise temperature when it's too low, and shade and cool surfaces to when it's too warm, to bring the body temperature back down. So these are again more behavioral external responses to maintaining body temperature. On the other hand, mammals like us and birds are endotherms, and we can maintain our body temperature through those mechanisms as well. We do behavioral strategies, but we also have more internal activities and physiological processes that are going to maintain our temperature. So we're supposedly warm-blooded creatures. All right, so these are mistaken terms, because both endotherms and ectotherms maintain pretty similar ranges of body temperatures. So, ectotherms are not cold, and compared to them, we're not warm. Okay. All right. So body temperature is very related to a surface to volume ratio for a species. All right. So the surface area determines heat loss, and the body volume determines how effective and efficient it is at generating heat. So therefore, smaller animals with smaller volume and a smaller surface to volume ratio, they have to work harder to maintain warmth than a larger animal does. All right. Now, in addition to those other evolved mechanisms, endotherms, ectotherms, animals adapt to their have physiological adaptations to their particular niche that they live in. So here's some different species of fox that have very different body characteristics that match their climate that they are in. So slim versus stocky bodies to correspond with that surface to volume ratio I was just talking about. The length of the limbs, length of the ears and tails, and so on, and color of their fur, not just to blend in with their environments visually, but also to reflect or to absorb sunlight to maintain temperatures. All right, so let's first talk about behavioral responses to temperature. Like I said a moment ago, some species, especially the ectotherms, are going to, they maintain body temperature by changing location, seeking sunshine or shade depending on temperature, changing their body position, curling up, stretching out. Some species change the color or even the volume and weight of their fur, shed fur during the summers and gain it during the winter time. Have different color fur and feathers during different times of the year to absorb or reflect sunlight. And then of course we humans, we don't do much of that, but we take on and put on and take off clothing and wear different, clothing that's our behavioral response to temperatures mostly. So the endothermic responses to heat and cold, we have responses to lower temperatures. And so, we'll shiver and blood vessels will constrict. Our thyroid will release different levels of hormone to boost or slow down metabolic rate, to heat us up, cool us down. Newborn animals increase activity of something, they have more brown fat cells, which helps generate more heat since they have that small volume and, the larger surface to skin to volume ratio that makes them, lose heat more rapidly than an adult will. So other responses to higher temperatures, we respire. Other species, some species will lick or pant, lick their fur, lick their skin to do the same thing that perspiration does for us. Dogs, for example, don't have sweat glands, and so they release their heat by panting. So blood vessels will dilate near the skin surface or constrict when it's colder. All right. So your book mentions something called Raynaud's disease, and I'm only going to mention this just as a personal curiosity here because about a year ago I was convinced that I had it. This will just be this is a disorder that will cause, as you can see in the image here, will cause parts of the hands to be cold in ways that they're not really, that don't match how the circulatory system would keep. Anyway, you see the tips of the fingers will get cold, and not the palm or even the lower parts of the finger. About a year ago, I was experiencing this, and it wasn't yet winter; it was last fall, and I started to notice that this finger would get almost icy cold even when it was quite warm out. And then indeed during the winter, it was, I had to double glove, and, sometimes that finger would just get almost frostbitten and numb. And the palm was fine, the rest of the finger was fine, other hand was perfectly normal temperature, but just that one finger would get icy cold. And in preparing this presentation for you right now, it occurred to me, I don't know when this happened, but this went away in recent months, and I didn't even really, it came on kind of gradually, and and it went away gradually, and I didn't even realize until just tonight, like, oh yeah, I don't have that anymore. My finger doesn't get cold. I hope that will last this winter too. Okay, so I don't know if I had like a little strange bout of Raynaud's disease, but I was experiencing this myself about a year ago, and earlier this year in the winter. All right, so I'm going to skip some things here. So I want to mention heat stroke is just a really insidious cause of harm and danger, and with our increasing climate crisis that we're experiencing, this is going to be, sadly, and continue. It's going to be a growing problem and continue to be the number one climate cause of death throughout the world. It gets too little attention. larger disasters like hurricanes and floods, particularly hurricanes get, great attention. And we're talking about increased, more hurricanes per year and stronger, every year seems to be, a new world record for numbers of hurricanes, and certain hurricanes are, they're just becoming worse and stronger, bigger storms. And I don't know, part of it I think is because we name them. We name storms, and heat waves, I forget the number, but heat waves kill, I don't know, I want to say about twice as many, or maybe 4 times as many people worldwide as things like floods and hurricanes do. But we don't name heat waves, so I don't think they get as much attention simply because we don't name them. It's hard to throw money at something. FEMA doesn't come in and rescue. I don't know. It's just hurricanes just get a lot of media attention and government attention, and it's really heat that is going to be a much more lethal problem for us. So, something fun to think about. All right, now I want to talk about brain mechanisms for temperature regulation. Okay, those are a bunch of adaptations and behavioral responses. So here's where things get a little bit complex, and where our psychobiology will kick in. All right, so there's we have spinal cord structures and brainstem structures, and the hypothalamus is going to be a star of things in this chapter. Okay, so if you remember, the hypothalamus is responsible for the 4 F's, and we're really going to be talking about a couple of them in this chapter, and it's key in thirst and maintaining fluid levels and temperature and hunger. All right, so the area that we're going to be focusing on for temperature regulation is the preoptic area of the hypothalamus. All right, so the hypothalamus, if you remember, you flip the brain over and look at it from the base. You can see the optic nerve coming in and form a chiasm, and the pituitary gland protruding out just below that. So the hypothalamus lies just above, or when we're looking down at it, just below the optic chiasm. All right. So the preoptic area of the hypothalamus is that area just right in front of the optic chiasm there. Okay. So the nucleus there, the preoptic area, is going to be key in responding to higher core temperatures. The posterior, the back part, the rear part of the hypothalamus responds to cooler core temperatures. Okay, so we have 2 different zones in the hypothalamus that are going to be responding and helping regulate behavioral changes and bodily changes when temperatures are detected in these 2 different ranges and directions. So we've got 3 types of neurons interacting in these areas and throughout the body that are going to respond to changes in core temperature. So we have warm sensitive neurons and cold sensitive neurons, and then we have temperature insensitive neurons. Okay. So these are the 2 areas that I was just talking about. I should have flipped over when I was telling you. So if we flip the brain over, there's that optic chiasm that we're talking about. The hypothalamus is just above it and below it in that image. Okay, so this area up here, this is the hypothalamus. Okay, so here's that optic chiasm. This structure, the X. Okay, and this is the preoptic area. This nugget part of the front of the of the hypothalamus is the preoptic area, and the posterior hypothalamus, these cluster of nuclei back here. All right, so there, the preoptic area promotes, like I said earlier, promotes heat loss. So it's going to help regulate for us perspiration and the dilation of blood vessels, in skin surface regions, okay, to help dissipate heat. The posterior hypothalamus is going to respond to temperature, cold temperature, and promote heat conservation. So it'll cause us to, increase shivering, of the muscles, and that helps generate warmth, and constriction of the blood vessels to prevent them from radiating heat and keeping the heat inside. It's in the blood. All right. So I'm going to skip this here. The hypothalamus itself responds to temperature differences. Okay, so as circulating blood reaches, goes through it, it is going to be detecting temperature changes, itself. All right, so the hypothalamus receives signals from sensors throughout the skin and throughout the body via the spinal cord. But heating or cooling the hypothalamus directly, naturally through blood supply, or if you artificially change the temperature of the hypothalamus, you can override what the receptors throughout the body are telling it. Okay, so that tells you, its own temperature regulation or perception overrides, what the rest of the body might be telling it. Okay, so that is a little quick overview of temperature regulation. In the next module, we'll talk about fluid regulation or thirst. Okay, see you there.